All right, Algebra 2 students, this is your little gift for helping you with your exam that you need to do this weekend for Chapter 5. This is, I think, my fourth or fifth attempt at trying to make this video. My PC was having issues and kept stopping the video after 3 minutes, so let's see if we get through this one. You're going to need to use your exponent rules to simplify some problems. Just a reminder, like if you have x to the third power times x to the second power, you would add your exponents, right? X to the fifth power, because that's the same as saying x times x times x times x times x. And you have x to the fifth power. If you have open paren 2x to the third power, close paren to the third power, let's say, that's a power. So that means the power on the outside of the parens applies itself to everything on the inside of the parens. So it becomes 2 to the third power times x to the ninth power, right? Because that means we have 3 x to the thirds. So we have a total of 9 of them. And then you would simplify the 2 to the third power to be 8. So it'd be 8x to the ninth. So remember your power to power. You will have some questions where you need to FOIL. You might have open paren 11x minus 2, close paren, open paren 2x plus 1. You would want to do your first terms times each other. 11x times 2x, your outer terms, 11x times 1, your inner terms, negative 2 times 2x, and your last terms, negative 2 times 1, and then you would combine all your like terms. So you know how to do that. You've been foiling very successfully during this chapter and unit. You'll need to do scientific notation. Just remember that scientific notation always needs to end up with only one digit in the ones place. So like 3.1 times 10 to the fifth. If you end up with 31 times 10 to the fifth, the decimal needs to move one more place to get it back to 3.1, and you would change your 10 to the fifth to 10 to the sixth. So remember that when you do your scientific notation problems. For your synthetic division, I'll do another synthetic division example with you. If you had something like, let's see, let's pull the example, 4x to the fourth, so open paren 4x to the fourth, minus x to the third, minus 19x to the second, plus 11x, minus 2, close paren, divided by, open paren, x minus 2, close paren. You'd want to write it down very carefully and then make sure it's in descending order from the largest degree down. This is a fourth degree, so we have 4x to the fourth, minus x to the third, minus 19x to the second, plus 11x, minus 2. Notice that we have a term for every position. We don't have to put a 0 in any place. Our divisor, divided by x minus 2, that's where we get our r value by setting x minus 2 equal to 0. Add 2 to both sides and x equals 2. Therefore, your r value is 2. So that's where you're going to start your synthetic division. Your first row is going to start with the 2. You might want to put a line like a 1, 2, 3 or a 4, 5, 6 in order to show separation in Braille. And then you're going to, the rest of your row, you're going to put your coefficients of your terms of your polynomials. So you're going to have a 4, a negative 1, a negative 19, an 11, and a negative 2. Then enter a couple times, go down in print and make a space and put a line. You can put a bunch of dot 3 6s together. And in that first column where the 4 is, you want to pull that 4 down below the line. So you're going to put the 4 below the line, and this is your starting point. You're going to multiply the r value times the 4. 2 times 4 is 8. You're going to put the 8 under the negative 1 in your next column. You're going to combine negative 1 and 8 to get 7. You're going to do 2 times 7 is 14. Put the 14 under the negative 19. Combine negative 19 and 14 for 5. Put the 5 underneath the 14. Do 2 times 5 is 10. Go over and put the 10 under the 11. 11 and 10 is 21. And then you would go 2 times 21 is 42. And then negative 2 and 42 is 40. Let me double check my work. For negative 1, negative 19, 11, and negative 2. I got to pull down the 4. 2 times 8 is 8. 14, 2 times 5 is 10. 11 and, oh, excuse me, I made a mistake here. This is a negative 5. I'm checking my work. 2 times negative 5 is negative 10. So we'd have an 11 and negative 10, which is a 1, and then 2 times 1 is a 2. So we want to put a 2 there to get the 0. So notice I went back and double checked my multiplication and combining to make sure. And where's a common mistake? To miss a negative. And I did, when I went negative 19 and 14, I put a 5 instead of a negative 5. All right, so we have 4, 7, negative 5, 1, and 0 underneath our line. So now we're going to write out our quotient. Because we were a 4th degree in our dividend, we're going to start at a 3rd degree. So it's going to be 4x to the 3rd plus 7x to the squared minus 5x plus 1. And because there's a 0 at the end, there's no remainder. Right? If there was a remainder, we would put that over our divisor of x minus 2. So that's a quick example and reminder of synthetic division. You will have a couple of problems like that, at least one on your test. Then you'll also need to do factoring. Remember to use all of your resources for factoring. Greatest common factor is your first line of defense when you factor. The grouping method is the next line. Your AC method with grouping is another line, another tool. And then finally, kind of your special rules with your difference of squares and perfect squares. Okay, so those are the different tools you're going to use for factoring. And we can do an example, like a basic example. How about let's do how about 200 x to the second power minus 50. Well, notice they both could share a 50, so that's our GCF. We're going to pull out 50, our greatest common factor. So we have 50 open paren, and what do we have left? 4x to the second minus 1. Then notice 4x to the second. 4 is a perfect square, 1's a perfect square, and it's a difference, right? So we're going to use that tool, and we're going to know we have 50 open paren 2x minus 1, close paren, open paren, 2x plus 1, close paren. We checked it with our FOIL. We would get back to the 4x squared minus 1 and then times it by 50, and we would get back to 200x squared minus 50. So this is using a GCF and one of our special factoring tools. You could also use the AC method. Like if we had, let's see, what if we had, we use GCF and the AC method. What if we had x to the 4th minus 7x to the 3rd plus 12x to the 2nd? Notice that you can have a greatest common factor on this of x to the 2nd. So you pull that out, and you're left with x to the 2nd minus 7x plus 12. So you just focus on that, close paren, you just focus on that x squared minus 7x plus 12. Well, your AC is 12. What two factors of 12 are going to get you your B, your minus 7? Well, they would be negative 4 and negative 3. So we're going to just use those. We don't have a coefficient on the x squared, so we just get to say that it's x squared open paren, x minus 4 close paren, open paren, x minus 3. Now, if you had a coefficient on your x, you'd need to do the grouping tool also. So that used GCF and our AC method. So use all those tools of factoring to make your way through the problems in regards to factoring completely. Simplifying radicals. Just remember, a radical can be broken up into kind of their quote-unquote factors. So like square root of 125, you could break that down into square root of 25 times square root of 5. So the square root of 25 is 5, so that would be 5 square root of 5 is going to be the simplified form of the square root of 125. So you're going to break those down. If you have variables, maybe you might have a variable underneath, like, you know, the square root of 9x to the 6th. So this could actually be the square root of 9x to the 3rd to the 2nd, right? And then it's the square root of 9. So then that would be 3, and it'd be x to the 3rd, right? So you can break up your exponents also. Those are radical rules. Remember to rationalize your denominator. So if you have something like 9 over the square root of 3, you don't want a radical in the denominator, so you would rationalize that by multiplying it by the square root of 3 over the square root of 3 in order to get the denominator to be a real number. So the square root of 3 times the square root of 3 is the square root of 9, which is 3, right? And then 9 times the square root of 3 would go in the numerator position, and then simplify it further. If you have 9 square root of 3 over 3, you know the 9 and the 3 in the numerator and then the denominator position, those could reduce, right? 3 goes into 9 3 times, so your final answer is 3 square root of 3, all right? So remember to rationalize that denominator. You also rationalize the denominator with conjugates. So if you have something like 5 over 4 minus the square root of 2, again, we don't want a square root or a radical in the denominator, so we have to rationalize that with the conjugate. So the conjugate of 4 minus the square root of 2 is 4 plus the square root of 2, right? 4 plus the square root of 2, because when we FOIL that, those inner outers, inners are going to cancel. So all we're looking at is the first term, last term, and then they combine to be a real number. So if we FOIL 4 minus the square root of 2 times the quantity of 4 plus the square root of 2, we'd have 4 times 4, which is 16. And then our outer is 4 times square root of 2, and our inner is negative square root of 2 times 4. Well, those cancel. So then we're just looking at the last, the negative square root of 2 times positive square root of 2 is just going to be minus 2, right? And so that would be 16 minus 2, so we'd get 14 in the denominator position. Then in the numerator position, we're going to either FOIL it if it's two quantities, or we're just going to distribute. So in this case, it's the 5 distributing to the 4 plus square root of 2. So 5 times 4 is 20, plus 5 times square root of 2. And then we could break this apart if you wanted to and simplify it, because this is the same as 20 over 14 plus 5 square root of 2 over 14. So the 20 over 14 would become 10 over 7. So we could have 10 over 7 plus 5 square root of 2 over 14. However, if you leave it at 20 plus 5 square root of 2 over 14, and you can't simplify all of them, you know, pretty, you can leave it like that, and that's still good for this exam. So those are some radical rules. Remember that like something to the negative exponent means you inverse it, right? So x to the negative 2 over 3 actually means 1 over x to the 2/3. And then that's a radical, isn't it? It's the cube root of x squared, so we'd need to rationalize that. You would rationalize that by multiplying it times x to the 1/3 over x to the 1/3, right? Because 2/3 and 1/3 added together becomes 3/3, which is 1, and x to the 1 is x. So you'd actually have the cube root of x all over x. Okay? All right, so there's a little review on negative exponents. When you need to solve equations that have radicals or roots on each side, you need to undo them by doing the exponential power that would undo them. So if it's like the square root of x plus 2 equals 6, you would square both sides, right, to get rid of that square root. So you'd actually have x plus 2 equals 36. You'd subtract 2 from both sides and you'd get x equals 34. If it's a cube root, you're going to cube both sides, right? If it's a sixth root, you would do the sixth power to both sides. So those should go okay for you. And then you're going to have some problems with your I values, your complex numbers. Remember your I cycle. I means the square root of -1. I to the second power would mean the square root of -1 times the square root of -1, which is -1. I to the third power would be I squared times I. So if I squared is -1, it would be -1 times I, which is -I. And then I to the fourth power would be the same as I squared times I squared, which is -1 times -1, which is 1. And then like I to the fifth power would be an I to the fourth times I. So that's going to be a 1 times I, or just I. It just repeats itself. So remember your I cycle, okay? And apply all those definitions of your I to simplifying the problems that involve a complex number. And I think that is it in regards to the review that's going to kind of give you a little boost with your exam. So spend some time this weekend. It's 20 questions. You're going to want to set aside a few hours to review video and examples and really take your time with each question. Good luck. See you next class.